No. Okay, but I bet if he's really smart, he knows better than to not do any of his homework. Okay, so do your homework. Okay, rant over. Let's go. Okay, so look at your graph. Relative minimum, okay, would be here. That's the lowest local point in that section of the graph. How low is it? 0. Where does it occur at? 0. Okay, the second one, I guess that should say maximum. Let's change it. Okay, oh crap, leave it a minimum. The maxes are down here. I'm stupid, sorry. Okay, so leave it a minimum. Okay, the absolute minimum, here's the difference. A relative minimum, you're looking for your graph to go from down to up, yeah? Okay, but the absolute minimum can be the lowest point anywhere. Where's the lowest point on the graph? Negative 4. Where does it occur at? X equals negative, we'll say 6, sure. Okay, now let's do maximum. So where do I have a relative maximum? Okay, it's at negative 1. What is it?
2.
Well, I'd probably say that's 1, yeah. Okay, now the absolute maximum is where? Okay, it'd be over here. It's 4. It occurs at 2. Okay, so what you should understand hopefully from this, I know it's kind of easy. Okay, but your relative min or max is the y value. It occurs at an x value. Okay, go down to number 2. Relative minimum, what is it? It is 1. It occurs at 4. Okay, but my absolute minimum is
0, 0.
okay, 0. It occurs at x equals 0. Okay, my relative maximum is what?
3, and then x equals 2.
Open circle.
Doesn't count.
None.
Oh, GG's.
Okay, now, even though I don't have a relative, do I have an absolute?
Yes. No.
You do have the highest point.
I do? Where?
I mean, it's right below 5.
Okay, now let's talk about that. So you're like, okay, well the biggest number is like just a little bit less than 5. So you're like 4.999. Could I get closer? 4.99999? Sure. Could I get closer than that? 4.99999. Yeah, you get the idea? Okay, so if it's open, I can't say what the highest point is. Okay, because I can always tack another 9 onto the end of that and say it's a little bit closer. So if that's open, I can't say 5 is the biggest, and I can't say 4.999 is the biggest because I can always get closer. Okay, so go down to the next one. Relative minimum, what is it? Doesn't exist. I don't have a sign change from what to what? Negative slope to positive slope. That's a minimum. Okay, but I do have an absolute minimum. What's the absolute lowest point on the graph? Negative 1. Now, where does it occur at? Okay, now look closely at both of those. Only negative 1. Now, could it have occurred at both points? Sure. Okay, you can have 2 people that got the highest grade. You can have 2 people that got the lowest grade. Okay, but that doesn't change that grade was the highest or the lowest. Okay, relative maximum, what is it? 2, it occurs at 3. Now, let's talk about something real quick. Go back to graph number 2. What is the slope at this relative minimum? F prime of 4 equals 0. Because what kind of slope is it? It would be flat. Okay, now look at 2. What is the slope here? Undefined. F prime of 3 is undefined. Let's talk about why. Okay, because you have a cusp. Now, do you remember when you find critical numbers, what 2 things are you looking for? F prime to be 0 or F prime to be undefined. So both of those count as critical numbers. Okay? Then what's the absolute max here? Same thing, 2 at 3. So keep in mind that just because you have a relative, it doesn't mean it can't also be the absolute. Okay, one more left. Relative minimum. So what you have here, this graph, I just pulled it off Google. Okay, it's going like this, and then it's asymptoting towards that line. Okay, so do I have a relative minimum? Yes, what is it? 0. It occurs at 0, but do I have an absolute minimum? Look at the other half of the graph. No, because where are these sides going to? Negative infinity. Yes, Lance.
Number 3.
Uh-huh.
Is the relative minimum not the same as the absolute minimum?
Because a relative minimum has to have a slope change from negative to positive. So if these are endpoints on my graph, I can't show that f prime, which is the slope, changed from downhill to uphill. That's why. Okay, relative maximum, do I have one? Yes, it occurs at negative 8. I'm sorry, I said that wrong. It is negative 8. It occurs at negative 2. Okay, but do I have an absolute max? No. Turn the page over to the back. Okay, quick, easy little problem set here. Okay, look at each one of those. We're only going to do absolutes. So look at graph A. Do I have an absolute max and an absolute min? Okay, this is the absolute max. This is the absolute min. Okay, look at letter B. Do I have an absolute max and an absolute min? Okay, absolute max would be here. Absolute min would be here. Okay, next one, letter C. Do I have an absolute max and an absolute min? No, which one do I not have? Okay, this is not an absolute max, but I do have an absolute min. Okay, look at graph D. Do I have an absolute max and an absolute min? Which one do I not have? Oh, I have a max right here, right? Okay, so be careful. It doesn't have to be an endpoint. Absolute max just means one point is higher than all of the other points. Okay, look at graph E. Do I have an absolute max and an absolute min? Which one do I not have? Don't have a max, but I do have a min. Absolute min is here. Okay, letter F. Do I have an absolute max and an absolute min? No. Absolute max, this keeps going up forever. This keeps going down forever. So I have neither. Okay, last graph, look at G. Do I have an absolute max and an absolute min?
Yeah.
Yes. Now, how many times does the max happen? 1, 2, 3. But do I still have one y value that's the highest? Yes. So this is the absolute max. Even though it happens more than once, it's still the biggest y that my graph ever goes to. Okay, notice I also have an absolute min. Okay, and it occurs 3 times on the interval. Okay, so look at all the graphs, and I want you to come up with the conditions necessary for me to guarantee that I'm going to have an absolute max and an absolute min. So look at your graphs, look at the ones that had them versus the ones that only had one or only had the other or maybe didn't have either. What seems to be the big difference? Think about it. Okay, you have 7 graphs plus the graphs on the front. Yes?
Connected graph with no breaks.
Perfect. Okay, now let's talk about endpoints though, because this guy is connected, right? It doesn't have any breaks. But what about the endpoints? They also have to be closed endpoints. So, come down to what conditions are necessary. Has to be a continuous graph with closed endpoints. Okay, so guess what? There's a theorem that says that. Okay, so we're going to learn it. It's called the extreme value theorem. Now think about extreme means like the most. So the most biggest y, pretend that's good English, and the most smallest y, the extreme values of the function. Okay, so here's what it says. I must attain both an absolute max and min if f of x is continuous on a to b but closed. Now, think about the graph on the front that had the cusp. Does it matter if it's differentiable? No. All that matters is it has to be connected, and I have to have endpoints. Now look at graph F, okay, that has an asymptote. Okay, that would not count as continuous even though it does have closed endpoints. So here's the theorem. Put a big star right here. Okay, if f of x is continuous on a to b closed, then there must exist an x equals c within a to b such that f of c is greater than or equal to f of x for all x's within a to b. Okay, now all of those are going to be brackets. Every single one of those is going to be a bracket. Okay, there's another one that says there are two conclusions for this. An x equals c within a to b such that f of c is less than or equal to f of x for all x's within a to b. Okay, and then we're going to label one of those is promising you have an absolute max. One of those is promising you have an absolute min. Which one is the first one? A max or a min?
Max is first.
Okay, it is a max. Let's talk about why. I'm promising that there's a c, right? That's the point I'm picking. So that f of c is greater than all the other y values on that interval. That's a max. Now look at this one. What's this one? My f of c is less than or equal to all the other y values on the interval. Now let's talk about the equal to. Why is it less than or equal to? Because there could be other points that have that exact same y value, right? So remember we talked about your max or min can occur more than once. That's not a problem. Okay? Alright, so we're moving to your notes now. And then maybe actually on here let's label this is an absolute max because it's greater than all the other y values. This is an absolute min because it's less than all the other y values. And then when you're ready, we're going to our notes.
So which means that the highest value, so x equals c is like the highest value.
X equals c is where the highest y value occurs. So the y value, f of c, is the highest value. Okay, good to go? Alright, notes for today. So we're going to do first derivative test, but we're going to look for absolute extrema. So the only difference, f of x equals is that you're going to be finding absolute extrema on -2 to 3. So all of your instructions for the last 2 days said to find relative extrema. Now we want the absolute biggest on -2 to 3. Okay, so the beginning part starts off the same. You're going to take the derivative, set it equal to 0, find your critical numbers. So do that first. Okay, f prime, what are we going to get? 3x squared minus 6x, we're setting it equal to 0, or undefined if it was a fraction, but it's not, so we don't have to worry about that here. Okay, take out a 3x, what's left over? X minus 2, which means that my two critical numbers are what? Okay, good. X equals 0 and positive 2. Now, if I want to know what kind of max and what kind of min these are, I can do a sign chart, just like we did yesterday. So 0 and 2 go in here. Pick a number bigger than 2. 3. Okay, what's 3 times 3? Positive 9. What's 3 minus 2? Positive. Times 2 positives, get a positive. Okay, between 0 and 2, say I pick 1. 3 times 1 is positive. 1 minus 2 is negative. What's the product? Negative. Say I pick smaller than 0, maybe negative 1. 3 times negative 1 is negative. Negative 1 minus 2 is negative. Multiply 2 negatives, get a positive. Those are the signs for f prime. What do they tell us about f? Goes up, then it goes up. So this is the relative max. Bless you. This is the relative min. Now, here are the options for the graph, and there are a bunch, but just kind of think about for a second. My graph could go like this. We'll say options. Okay, it could go like this. Then where would the absolutes be? At the relatives or at the endpoints? The endpoints. Or it could go like this. And then where would the absolutes be? At the relatives. So the only way for you to know where the absolutes are is to do what's called a candidates table. It's not hard. You're literally going to make a table. You're going to put in it the critical values that you got and the endpoints. So, what are the endpoints for the interval I'm looking at? Negative 2 and 3. And then what are the critical values that I got? 0 and 2. Now, keep in mind that I want to compare y values. So when I plug those numbers in, what should I plug into? F or f prime? F. So label right here, this is f of x. Okay, because I want to compare the y values at those points. So let's say I'm plugging in negative 2 first. Remember, I'm plugging into the original, which is right here. So I'd have negative 2 cubed minus 3 times negative 2 squared. Okay, well, negative 2 cubed is what? Negative 8. Negative 2 squared here is 4. Multiply that by minus 3, I get minus 12. Negative 8 minus 12 is negative 20. So at negative 2, my y value is negative 20. At 0, plug in here, what do I get? Easy, it's going to be 0. Next, we're plugging in 2. So I'd have 2 cubed minus 3 times 2 squared. Okay, well, 2 cubed is 8. 2 squared times 3 is minus 12. What's 8 minus 12? Negative 4. And then at 3, I'd have 3 cubed minus 3 times 3 squared. Well, that's 27. That's 27. If I do 27 minus 27, I get 0. So let's sketch the graph just for fun. Okay, here's what my graph would look like. Negative 2, 0, 2, and 3. At negative 2, I'm way down here at negative 20. At 0, I'm at 0. At 2, I'm at negative 4. And then at 3, I'm back at 0. Let's sketch our graph. Doing, doing, doing. What is my absolute minimum? Negative 20. Where does it occur at? Negative 2. What is the absolute max? 0. Where does it occur at? Two numbers. 0 and 3. Make sense? So my absolute min is negative 20. It occurs at x equals negative 2, which was an endpoint. But my absolute max occurs at 2 places. It's 0, and it occurs at x equals 0 and 3. Make sense? But my relatives are still kind of like their own little winner, but they just don't win overall. Okay, so this is called a candidates chart. So if you hear me say that, that's what that means. It's a candidates chart over here. Good? Okay. We're not going to do a million of these. I think we have like 2 more maybe. And then we're done. Okay, so next one. Here we go. Number 2. Okay, our function is going to be y equals x plus 2 sine x. And we're going to look on the interval from 0 to pi. We're finding absolute extrema. We're finding absolute extrema. Okay, what do I do first? Take the derivative. Y prime equals. What's the derivative of that?
2 something cosine.
2 cosine x. Then from there I set it equal to 0. Okay, then from there I need to solve, so I'm going to subtract the 1 across. Now it's a negative 1 equals 2 cosine x, then what? Divide by 2, so I know that cosine x needs to equal minus a half. Okay, remember, from here you're just doing your unit circle backwards. So cosine, I want 1 finger. Who do I want? 1 finger, then bend the next guy. Pi thirds, yeah? So pi thirds is going to be my reference angle, but I need it to come out negative. So let's think about x is going to be pi thirds. All students take calculus. So where will it be negative from 0 to pi? I'm not even looking down here.
2 pi thirds.
2 pi thirds. Now, it also would have been negative at 4 pi thirds, but since that's not on my interval, I'm not going to consider that. So, 2 pi thirds, that's my guy. Now, question. If I'm going to end up putting these guys into a table, does it really matter if they were relative min or relative max? They're going in the table either way. So a sign chart is unnecessary unless you have to find relatives and absolutes. I don't have to find relatives. Didn't ask me to, so I'm just going to go straight to my chart. So Canada's chart goes here. What types of things go in the chart? 2 types of things. The x values of the critical numbers and the endpoints. So 0 and pi are my endpoints. And 2 pi thirds was my only critical number. What am I plugging those into, f or f prime? F of x, the original. Because remember, I want to compare my y values. Okay, let's do 0 first. So, we're plugging in 0 to this guy right here. So I'm going to have 0 plus 2 sine 0. Okay, well, sine 0 is what? 0. 2 times 0 is 0, plus 0 is easy. Okay, let's do pi next just because it's easier. Okay? So I'm going to have pi plus 2 sine pi. What's the sine of pi? 0. So this is 0. Is the whole thing 0? I'm adding a pi to it, so it would have been pi. Okay, next we need 2 pi thirds. So it's 2 pi thirds plus 2 sine 2 pi thirds. Okay, so let's think about pi thirds is here. Sine's on bottom, so it's what? Root 3 over 2. So I have 2 pi thirds plus root 3 over 2 times 2. So far, so good? Okay, what's going to happen with the root 3 over 2 and the 2? They're going to cancel out, so these guys are gone. So really, my answer is 2 pi over 3 plus root 3. Now, some of you guys, there was a question on your test 1 where it was like pi squared plus 6. And you were like, well, how am I supposed to know what it is? You don't have to know exactly what it is. You just have to estimate what's bigger. So think about, this is pi, that's about what? 3.14, yeah? Okay, now think about here. I'm going to do 2 times pi. What's that about? 6. And then I'm going to divide it by 3. That's about what? 2. Okay, so this is about 2. And then I need to add root 3. Actually, that's kind of hard to do in your head. Usually on the AP test, it'll be obvious. But root 3 would be, I don't know, do you have a calculator? This one, I guess you can't really do in your head.
1.3.
Let's do 2 pi over 3 plus root 3. Okay, that's 3.82. What did you guess? Were you close?
He gets 1.3.
Okay, and that's what we're adding. That's close. Okay, so from there, looking at those two guys, who's bigger? Okay, this is the max. What's the min? 0. So you would write the absolute max is 2 pi over 3 plus root 3, and it occurs at x equals 2 pi thirds. Okay, then my absolute min is 0, and it occurs at x equals 0. Now, would you have had to put those parentheses? No, I just put them, I don't know why, because. Good. Okay, last one. The last one. Good. Okay.
Stop straight. Keep blocking my view
I wasn't even doing it.
on purpose.
Turn the page, last one, number 3.
We're good.
Last one. Y equals 2x minus 3 root 3x squared. Okay, we're going to do it on -1 to 8. Here we go. Take the derivative. What is it? Actually, before I take the derivative, I need to do a rewrite. What would my rewrite be? 2x minus 3x to the 2/3. Remember, I can't take the derivative until I switch it out of radical form into power form. So derivative y prime would be, derivative of 2x is 2. What is 2/3 multiplied by 3? 2, and x is now to the what power? Good. -1/3. Because 2/3 minus 3/3?
Oh, yeah.
Yeah. Okay, so from there, that's the same as 2 minus 2 over cubic root x. Everybody good to there? Yes? Okay, and then what do you do when your y prime or f prime comes out to be separate terms, not one big term? Common denominator. Good. So I'm going to put a cubic root x here. I'm going to put a cubic root x here. Okay, you cannot do a sign chart on multiple terms. They have to be one big term. So from the top, what can I pull out of both of those guys? 2 cubic root x minus 1 would be left over. On the bottom, I have a cubic root, bless you, x. So that's y prime. What is my critical number from the bottom where x is kind of by itself? 0. What's my critical number from the top? What will make that 0? 1 minus 1, right? So 0 and 1. Now keep in mind that if you were confused about how to do this, if you just set that equal to 0, you could have done it by hand, right? Add the 1 across, cubic root x equals 1, and then cube both sides. 1 cubed is still 1. So if you want to do any of those by hand, if you can't just see it, that's okay. Set it equal to 0 and then formally solve. Yes?
I'm just confused on how you did that. 0 first.
Because I set the top term equal to 0 and I set the bottom term equal to 0. Because remember what we had talked about, critical numbers can make the derivative 0 or undefined. Okay? So from here, could we make a sign chart? Could we? Sure. Are we going to? No. Okay, if I want absolute, I'm going to skip that. Now, my endpoints for what? -1 and 8. What are my critical numbers? 0 and 1. And then remember, you are plugging in to regular f of x, not the derivative. So let's do -1 first. I have 2 times -1 minus 3 cubic root -1 squared. 2 times -1 is -2. What is -1 if I square it and cube it? Order doesn't matter. positive 1. If I cubic root first, I get another negative 1, but then I square it, it turns positive. If I square it first, it turns to positive 1. Cubic root it, it stays positive. So that's 1 times 3, which is 3. Subtract negative 5. Next one, we're plugging in 0. 2 times 0 minus 3 times the cubic root of 0 squared. Okay, well 0 times anything is gone, 0 times anything is gone, overall it's 0. Okay, plug in 1. 2 times 1 is, okay, good, minus 3 cubic root positive 1 squared. Well, that's really just a 2 minus 3. And 2 minus 3 is negative 1. Last one left, 8. 2 times 8 minus 3 times cubic root 8 squared. 2 times 8 is what? Minus. Okay, do the root first. What's the cubic root of 8? 2, then square it. 4. 4 times 3 is 12. 16 minus 12 is 4. Absolute min is what? At x equals negative 1. Absolute max is 4 at x equals 8. Make sense? Okay, good. So here's the plan just for the next 2 days. Or, well, today and Monday. So tomorrow, pep rally, I give up, day of fun, you can do what you want. Okay, if you don't do your homework though, you're ridiculous, okay? You have one homework that's due. So use your time wisely. On Monday, I'm going camping this weekend. And I'm taking a sub on Monday because this week has sucked and I'm ready to not be here. So, love you, but I'm going to give you notes.
Self-care, queen.
Thank you, yes. Okay, so you're going to have a sub. She's going to play notes. You're going to take the notes. Got it? And then on Tuesday, if you have any questions from the notes, we'll go over them. Good job.
I'm gonna be there.